limiting reactants. Now, in your book, this may be called limiting reagent. Don't get confused. They are the same thing. Limiting reactant, limiting reagent, same thing. The limiting reactant is a reactant that limits the amount of product produced. Basically, it's the one that runs out first. And when that reactant runs out, the reaction stops and no more product is produced. So that's why it's important. It controls the amount of product produced. Okay, the steps to find limiting reactant. First, you need to balance your equation, always. Sometimes the problem doesn't really say anything about a limiting reactant, but I'll show you what the problems will look like and how you'll know you'll have to find the limiting reactant. In order to find that limiting reactant, pick one given amount and use it to find the amount of product produced through stoichiometry. So this is just an application of the stoichiometry that you already know. Do another stoichiometry problem. That's your step 4. This time, use the other given amount and use it to find the amount of product produced. And then step 5, whichever reactant produces the least amount of product is the limiting reactant. Least. And that amount of product is the amount of product produced. Okay, so here's my example problem. It will come with an equation as well. First thing we want to do is balance that equation. And let's see, I need to put a 2 here and a 2 here. We'll go ahead and make our map. So 7 grams and 5 grams of oxygen. Okay, and they want to know how much CO2 is produced. And we'll do that in grams. So in this particular problem, I have taught you with stoichiometry, you always start with the number given in the problem. Well, here, they give you 2 amounts. And so if you ever wonder, which one do I start with? The answer is you've got to find the limiting reactant. That is your key on when you know you have to find the limiting reactant. Because you'll notice this example problem says nothing about finding the limiting reactant. It is just something you have to do. So we're going to pick one given amount. So our 7 grams of CO, and we're going to go to the question mark, to the carbon dioxide. So, can I use mole ratio? Now it's just a stoichiometry problem like you did before. The answer is no, so we have to use molar mass of CO. The molar mass of CO is 28.01 grams in 1 mole of carbon monoxide. Now, can I use mole ratio? Yes, because I have moles here. So, moles of CO, and then moles of where the question mark is, CO2. You fill it in with the coefficients 2 and 2. Now I have the moles of CO2, but I need to go to grams, so I'll go ahead and do that. And moles of CO2, in 1 mole of CO2, it's 44.01 grams of CO2. Now it's everything on top multiplied together, divided by everything on the bottom multiplied together. And in this case, we get 7 times 2 times 44.01 divided by, and then all in one parentheses, 28.01 times 2. And I get, with 2 sig figs, 11 grams of CO2. Now that means that if all 7 grams of my carbon monoxide, all of this gets used up, I'm going to produce 11 grams of CO2. All right, I'm just going to get rid of that circle there so it doesn't confuse us later on. 11 grams. All right, so now we know how much 7 grams of CO would produce. Now let's see how many grams that my 5 grams of oxygen will produce. So I'll start with my 5 grams of oxygen, and I'm going to go to CO2 as well. So can I use mole ratio? No, because I have grams, so I need to get grams per mole, so 32 grams in 1 mole of O2. Now I can use mole ratio, mole of O2 to moles of CO2, and it is 1 and 2, because those are the coefficients. 2, 1, that's an understood 1. Moles cancel out. Now I have moles of CO2 to go from moles to grams, because that's what I need. I need to use molar mass, so mole, 1 mole of CO2, I have 44.01 grams of CO2. Now all I have are grams of CO2, Everything on top multiplied together divided by everything on the bottom multiplied together. 5 times 2 times 44.01 divided by 32. And I get, with 2 sig figs, that would be 14 grams of CO2. Okay, now, don't leave your problem like this. The question asks how much CO2 is produced. That is going to be the least amount. And 11 is smaller than 14, so this is how much CO2 is produced to answer the question. And the reactant that produced it is CO. So limiting reactant, LR, equals CO. Okay, so that's how you're going to find your limiting reactant. Now, as a part B to this type of problem, a lot of times you get a second question like, how much excess reactant remains? Well, you must use the amount of the limiting reactant given in the problem for all further calculations. This is very, very important. Students that don't do well on this assessment are ones that forget this point right here. After you have identified the limiting reactant, it controls the reaction. It's the one that is going to determine all the other amounts. So you must use the amount of the limiting reactant given in the problem for all further calculations. So I'm going to go through the steps on how to solve this like part B of a problem, how much excess reactant remains. So step 1, identify the excess reactant. One of them is limiting, the other one I'm going to have leftover of, so that is your excess. Calculate how much excess reactant is used. Start with the limiting reactant in dimensional analysis, always. And step 3, subtract the amount of excess reactant used from the amount given in the problem. So I'm going to work this problem here. Go ahead and go back up to this problem here. And I'm going to work with this equation and follow these steps. All right, in the previous problem, CO is my limiting reactant. So that means oxygen must be my excess reactant. I have 7 grams of this. I had 5 grams of this. I already know how much carbon dioxide I'm going to use. So in step 2, calculate how much excess reactant is used. So I have to start with my limiting reactant. I want to know how much of this is used. So that's where my question mark is. So 7 grams of CO. You must start with the amount of limiting reactant. And we're going to go to the excess reactant. So can I use mole ratio? No, because I have grams right here. So then we need to use molar mass to go to moles. So 28.01 grams of CO and 1 mole of CO. Now, can I use mole ratio? Yes. I'm going to go moles of CO, and I'm going to go to the excess reactant, so moles of O2. Fill it in with the coefficients, 2 and 1. Now, I have moles, but I need to go to grams. And so, to go from moles to grams, it's molar mass. So, in 1 mole of O2, you have 32.00 grams of O2. That leaves me with grams of O2. And when you do this calculation, you end up with 2 sig figs that you have 4 grams of oxygen used. And it is helpful to write that word right there, because if all 7 grams of my CO get used up, which they are because that is my limiting reactant, it runs out, I am going to use 4 grams of oxygen. Now, the next part, step 3 down here. Subtract the amount of excess reactant used from the amount given in the problem. That will tell us how much remains, because that is the question. So, I had 5 grams of oxygen. That was given to me in the problem. And I subtract out the 4 grams that I used. So I end up with 1 gram of oxygen remaining. And that's how you work with limiting reactant.